Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. If you just watched my most recent video, you would have found out that we can use rectangles to approximate an area under a curve. But I did lead to what happens as you get more rectangles and it becomes more accurate. Obviously, we're not going to want to manually do that by hand. We could, but it's just not going to be ideal. So a couple things before we move on, though, is that we should know area above the x-axis is greater than 0, and below the x-axis is less than 0. So it is possible to have an area equal to 0. Okay, let's look at really quick the graph of sine of x from, let's see, negative pi to pi. So that would be this part, and so this area is negative, this area is positive, but see how this area cancels out that area, especially because it's supposed to be symmetrical? So this would have a net area of 0. Even if we did it from 0 to 2 pi, it would have a net area of 0 because the positive area cancels out the negative area. If you're trying to find the true area, then you have to break it apart, find the area, absolute value of the areas under each. But the net area is a net of 0. Okay, so when we see this symbol right here, it's a big fancy looking S, that is your integral symbol. Okay, it's on your calculator if you ever need it. It's under math. I think it's under number. Nope. It's under math. Number 9. And it brings up that. Our calculators can sometimes do integrals for us. They can do definite integrals. They cannot do indefinite integrals. And definite integrals are what we're talking about today. However, you are going to have to be able to show your work because you're in calculus. So just know that your calculator can check your work if you can fill in all 4 of those boxes. Okay, so my last video, we were discussing finding the area under the curve when f of x was x squared plus 2 and the interval was from 1 to 3. Okay, so there is a way to write that using integral. We would write integral 1 to 3, because that's those numbers, x squared plus 2 dx. Okay, so we would have 1, 3, x squared plus 2, x. And it's going to find us that 12.6 repeating, which I told you guys in the last video was the answer. But now we've got to learn how to do it by hand. Okay, so the theorem reads, theorem, rule, however you want to think about it. Anytime you have an integral from a to b of f of x dx, it's going to be the limit as n approaches infinity of the sum of f from I equals 1 to n, forgot that part, of f of x sub I delta x. Okay, so what does that mean? Well, we know that this is y times x, or base times height. That's really what this is right here. The sigma means the sum of. So what they're having us do is adding rectangle 1 plus rectangle 2 plus rectangle 3 plus all the way up to an infinite rectangle. Oh, so this is a way to figure out how to do it for infinite rectangles. Check. Okay. Some extra pieces that you should know. Delta x is going to be b minus a over n, which I did introduce in my last video. And x sub I is going to be a plus I multiplied by delta x. Okay? So that's how we're going to get, in my last video I had 1, 1.25, 1.5, right? So that's all that this is really doing. Okay? So this is the formula for an area, things like that. So before we get into putting this all together, let's practice just the summation part. So we're going to do the summation from I equals 4 to 9 of I plus 3. Okay, so we're going to start with I is 4. Then we'll do 5. Then we'll do 6. Then we'll do 7. Then we'll do 8. And our last one will be 9. And now that I've substituted all the numbers starting at 4, ending at 9 into this equation, I'm going to do the sum. So we have 7 plus 8 plus 9 plus 10 plus 11 plus 12, which is 57. Okay. Or what about the sum from 1 to 3 of 5i? Well, we'd have 5 times 1 plus 5 times 2 plus 5 times 3, or 5 times 1 plus 2 plus 3, right? Same thing? So 5, 6, this is 30. So I also did it the second time as doing it like 5 times the sum from 1 to 3 of just I. So we've just shown that a coefficient multiplier can be pulled out front. Okay, so some shortcuts. You just really need, some calculus teachers will give these to you, some will not, so keep that in mind. The first rule I definitely do not give my calculus students. The sum from I equals 1 to n of a constant. Well, let's think about that. That's like the sum from I equals 1 to 12 of 4. It's a constant, so when I plug in 1, I get out 4. When I plug in 2, I get out 4. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All 12 rectangles are going to have the same exact answer. The answer is always 4. So wouldn't it be easier just to do 4 times 12? Yeah. So that's what this rule is, to do the sum from I equals 1 to n. If this is a constant, it's just constant times n. Now for powers, now we're going to start using rules that I don't necessarily expect my students to memorize because we just don't use them often enough to really get them memorized good. So this would be n times n plus 1 divided by 2. I squared would be n times n plus 1 times 2n plus 1 divided by 6. And I cubed is n squared n plus 1 squared divided by 4. Sorry about that. Sorry about the dog noise. We apparently had an extra dog come visit us, so hopefully she's done talking about him for now. She can go lay down, right? So these 4 rules are just going to help us out so that we don't actually have to add if there's, 12 numbers up here. I don't want to have to add all 12 numbers. So these are going to be shortcuts or rules that we're just going to use. So let's look at the summation from I equals 1 to 10. Now these rules are only going to be good for a subscriptive I of 1. I didn't write that down every time. I should have. From 1 to n. Okay? These are not going to be for 2, 3, 4. However, if you ever do get a higher number, you can just do your sum and then subtract off the part that you skipped. So like if this starts at 3, you could do 1 to n and then 1 to 3 and then subtract. 1 to 2. Sorry about that. We are just going to focus in these videos of keeping it from I equals 1. So I can rewrite this as 1/10 the sum from I equals 1 to 10 of I plus 1. Or 1/10 the sum from I equals 1 to 10 of I plus the sum from I equals 1 to 10 of 1. So this is the I rule. This is the constant rule. Okay, they each need a rule though. So every time you do a summation thing, you need a rule. So we'll have 1/10 multiplied by, the I rule said n times n plus 1 divided by 2. And the constant rule said your constant times your n. Well, great. That's something I can now type in a calculator. I don't have to actually find all 10 answers and then add them all together. Okay, so we had 1/10 10 times 10 plus 1 over 2 plus 1 times 10. 13 divided by 2, or 6.5. Now, could we have done, put in 1, 2 divided by 10, plus 3 divided by 10, plus 4 divided by 10, plus 5 divided by 10, plus 6 divided by 10, plus 7 divided by 10, plus 8 divided by 10, plus 9 divided by 10, plus 10 divided by 10, plus 11 divided by 10, because my last one would be 10 plus 1. Whew, yes, we could have. But using the rules was so much better. And had this been 100, I would not have wanted to do that by hand. So definitely faster using the rule than it is using all the extra stuff. Okay. So now we're going to practice, a little bit more. Let's look at the limit as n approaches infinity from I equals 1 to n of 2 over n f of 1 plus 2 over n I. Okay. And actually what we're doing here is we're taking f of x equals x squared plus 2 on the interval from 1 to 3. Okay, which should look familiar. Okay. So the 2 over n is a multiplier. We can factor that out. The limit as n approaches infinity of 2 over n multiplied by the sum from I equals 1 to n, and now we need to find our f of x. So this would be 1 plus 2 over ni squared plus 2. Okay, so before we can do the summation rules, we have to do a little bit of algebra rules. Not a big deal. Limit as n approaches infinity of 2 over n multiplied by the sum from I equals 1 to n. I'm just going to do this out to the side. If I FOIL that out, I'll get 1 plus 4 over ni plus 4 over n squared I squared, and then we'll have that plus 2. So if I add like terms, I'll have 4 over n squared I squared plus 4 over ni plus 3. Okay. Okay, so now we've got the limit as n approaches infinity, whoops, not 8, of 2 over n multiplied by 4 over n squared. Notice I dropped the summation symbol. I'm going to input the I squared rule, which was n plus 1, 2n plus 1 over 6, plus 4 over n multiplied by the I rule, which was n plus 1 over 2, plus 3, which is a constant, so you use that constant rule. So I use the I squared, the I, and the constant rule. Now if you'll notice, we do not have a summation anymore, and we do not have any more i's, so we can do the limit as n approaches infinity. Back to limits, right? But we've got to simplify this thing down. Okay. So this n gets rid of one of those. We can make this a 2 and this a 3. 2 goes into 4 twice. N would cancel n. Okay, so let's see what we got here. The limit as n approaches infinity of 2 over n multiplied by 2 over n times 2n squared plus 3n plus 1 over 3 plus 2n plus 2 plus 3n. Let's see, we'd have 4n squared plus 6n plus 2 all over 3n plus 5n plus 2. That's still all multiplied by 2 over n. So the limit as n approaches infinity of 8n squared plus 12n plus 2 over 3n squared plus 10 plus 4 over n. Okay. So I'm going to take that first fraction, and I'm going to divide numerator and denominator by n squared using some of my limit process. The limit as n approaches infinity of 8 plus 12 over n plus 2 over n squared over 3 plus 10 plus 4 over n. Now I can finally put in infinity. So that would be 8 over 3 plus 10. Let's see, so 38 thirds. Okay, and if you recall, when I had done it here, we're getting the same thing. So instead of making a bunch of rectangles like we did in my previous video, we were able to use the limit process to get that. So how did I set that formula up? Okay, let's just go ahead and look at another one because we need to make sure we understand how to set the formula up. I'm just going to turn this paper over so I can start at the very top. we're going to do the integral from 0 to 3 of x cubed minus 6x dx. Okay, so a is 0, b is 3. So delta x is going to equal b minus a over n. And f of, we'll have our a value plus delta x I. So a value is 0. Okay? So keep that in mind. So we'll have the limit as n approaches infinity of the sum of all the rectangles where we have our base times our height. That's what we're really looking at. Okay, and this time I'm not going to factor the delta x out. I'm going to leave it in there. That way you can see the difference if you want. So for us, that'll be the limit as n approaches infinity of the sum from I equals 1 to n. Our delta x was 3 over n. Multiplied by, now I love it when a is 0 because it makes my life a lot easier, but I'm going to write it in. So we'd have 0 plus 3 over ni cubed minus 6, 0 plus 3 over ni. And we still have our delta x. That's where this 3 over n is coming from. So we input a plus delta xi in, and that is just delta x. That's all we're doing. Now that we've done that, now we're saying the sum of all base times heights. We need to simplify this out. Fortunately, the 0 doesn't mean anything, so I'm going to rewrite this a lot smaller. We've got 3 over n, 3 over ni cubed minus 6, 3 over ni. I dropped the 0 plus. Okay. So the limit as n approaches infinity of the sum from I equals 1 to n, 3 over n multiplied by 27 over n cubed I cubed minus 18 over ni. So we have an I cubed rule and an I rule. Okay. So the limit as n approaches infinity of 3 over n multiplied by 27 over n cubed. The I cubed rule was n squared, n plus 1 squared over 4. Minus the 18 over n times the I rule, n plus 1 over 2. Now we can close that out. Okay. I'm going to distribute that 3 over n into it, and approaches infinity, and I'm going back to 2 lines here. Come on. 81 over n to the 4th multiplied by n squared plus 2n plus 1 over 4. 18 times 3 would be 54. We'd have n plus 1 over 2. Okay, so I distributed that. Now, this n gets rid of one of those n's. This n here, these gets rid of 2 of these. So I would have the limit as n approaches infinity of 81n squared plus 162n plus 81 all over 4n squared minus 54n minus or plus 54 all over 2n. So if I do my division, the limit as n approaches infinity of 81 plus 162 over n plus 81 over n squared all over 4 minus 54 plus 54 over n over 2. That would leave us with 81 fourths minus 54 halves. Negative 6.75. Okay. We did 0 to 3 of x to the third minus 6x. And it's getting negative as well. Why is it negative? Well, let's just check this out. And we're looking from 0 to 3. Okay, we can definitely tell that there's more area under than there is above. That's why it's negative. So the negative area just happens to be more, and so that's why the overall area is negative. Okay, so a couple extra rules that we can also throw in here. Just to save you some time. We kind of talked about them. You can take the integration from a to b of c dx. Okay, so what that's saying is the area under the curve of a constant. Okay, so let's say our constant, here's our a, here's our b. Well, if our graph is constant and we're getting the area under the curve, isn't that just a perfect rectangle? Yes, it is. We can just find out how wide that rectangle is, multiply it by the height, and call it good. If you're doing the integration from a to b of two equations added together, you can actually just do a to b of your first one and a to b of your second one. Okay. If you have a constant multiplying your f of x, you can actually pull your constant out, which we did in the one example. And if you want, let's say you're trying to find a true area instead of a net area, you can actually, let's say you're going from A to C, you can actually split it up in the middle and go from A to B, and then do the same thing but go from B to C. So those are just some extra rules in case you ever wanted to, making sure that B is between A and C. So make sure that you got those summation rules down. And just one more time in case you did not get it, let's go over how to change from an integral to that summation. Okay? So anytime you have the integral from a to b, f of x dx, okay, you're going to have the limit as n approaches infinity of, forgot my sum symbol, from I equals 1 to n of f of x sub I times delta x. Okay? X sub I is going to be a plus delta x I, and delta x is going to be b minus a over n. You're just going to take those and plug them in, right? So there is other ways to do this, but this is the straightforward way for any time you get stuck.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.